Imagine flying deep in hostile airspace. Suddenly, the warning alarms scream. A surface-to-air missile locks on, and it's climbing fast. A standard fighter pilot might deploy flares, drop chaff, or pull into a sharp, punishing dive. The pilot of this plane has a completely different standard procedure. They just push the throttle forward, accelerate, and leave the missile behind. To understand how an aircraft gets that fast, we have to look back to the late 1950s. The CIA's primary spy plane, the U-2, had a fatal flaw. Enemy forces were successfully shooting them down over the Soviet Union. The United States military needed a replacement that could fly higher and faster than any weapon ever built. They laid out strict parameters. The new aircraft had to cruise at Mach 3 and operate above 85,000 feet. Hitting those targets required throwing out the rulebook. At Mach 3, aerodynamic friction generates so much heat that standard aircraft aluminum literally melts in midair. Building the next generation of overhead intelligence meant reinventing aviation from scratch. The impossible task of building this machine fell to legendary engineer Clarence Kelly Johnson and his team at Lockheed's highly secretive Skunk Works division. At Mach 3, the atmosphere itself becomes hostile. Flying at 3 times the speed of sound creates intense friction, subjecting the airframe to sustained temperatures well over 600 degrees Fahrenheit. To survive the thermal barrier, the Skunk Works team forged the new aircraft almost entirely out of titanium. Building a plane out of titanium created a highly unusual operational quirk. Sitting on the runway before takeoff, the SR-71 Blackbird famously leaked fuel right onto the tarmac. The Skunk Works engineers designed these titanium panels with intentional gaps between them. When the plane accelerated to Mach 3 and was subjected to the blistering heat of the stratosphere, those panels expanded, seamlessly sealing the fuel tanks mid-flight. Because the entire airframe essentially turned into an oven, standard jet fuel would have violently exploded. Engineers had to formulate JP-7, a highly specialized fuel designed specifically not to ignite under those searing temperatures. Defeating the heat barrier required designing a machine that leaked on the ground, just so it could function perfectly at the extreme edges of the atmosphere. At 80,000 feet, the operational environment is alien. The sky turns a dark shade of purple, and pilots can clearly see the curvature of the Earth. Operating up here poses a massive mechanical challenge. Engineers had to figure out how to keep enormous engines fed with enough oxygen in an incredibly thin atmosphere, all while traveling at 2,000 miles per hour. The answer lies in the Pratt & Whitney J58 turbojet engines, specifically their defining feature, the massive, automated inlet spikes protruding from the front. As the aircraft accelerated, these spikes automatically pulled backward. This precise movement captured and compressed supersonic shockwaves, slowing the air down to subsonic speeds before it hit the engine core. At high speeds, the engines effectively operated as ramjets. Moving at Mach 3 over the curvature of the Earth meant traditional navigation tools were completely useless. Pilots had to rely on specialized inertial systems and celestial navigation, literally tracking the stars to guide their path. This combination of thermal engineering and hybrid propulsion resulted in a flawless combat record. Out of 32 aircraft built, they surveyed vast swaths of hostile territory, and 0 were ever lost to enemy fire. The SR-71 delivered absolute operational dominance. From its cruising altitude, a single Blackbird could photograph 100,000 square miles of territory in just 1 hour, all without crossing into hostile airspace. Its performance records remain unbeaten today. On July 28, 1976, the Blackbird set an absolute 3.3, alongside an altitude record of 85,069 feet. Even on its final flight in 1990, it maintained its reputation, traveling from Los Angeles to Washington, D.C. in exactly 64 minutes and 20 seconds. But the specialized requirements that made the Blackbird untouchable also made it incredibly expensive to operate. The custom fuel, the rigorous maintenance, and massive support teams meant every single flight cost millions of dollars. By the late 1980s and early 1990s, the military began shifting its intelligence budgets. They directed their focus away from high-speed manned aircraft, pouring resources instead into stealth bombers and growing satellite networks. Retiring the fleet was highly controversial.
Intelligence insiders argued that satellites, constrained by predictable orbits, could never match the real-time flexibility and unpredictable paths of an SR-71. Enemy missiles never caught the Blackbird. Ultimately, budget spreadsheets and shifting strategic doctrines grounded the fleet. Today, it rests in museums, a physical monument to the moment American engineering proved that extreme speed and altitude are the ultimate defense.